Today we discuss about the topic is product design for manufacturing. In the topic we discussed about the basic things are the design principles. Okay, there we go. The first thing is design for manufacturing. Why we need the design for manufacturing? Because we have to design in every component. We have to design a single component. It requires a design process. That means we manufacture a single component now. It requires a design. So we have a set of standards like this. So for that, we follow the procedures to complete these things. So that's the required for the component design. So that means it means the design for is of manufacture for the collection of parts that will conform to product after assembly. So we have to manufacture a component based on the design principles. So the types of designs are original design, adaptive design, redesign, variant design, selection design, and then industrial designs. So the first of all we discuss about the thing that original design. So original design is that we implement a new components. That is like invention. So it is called as the original design. Before we did not use that component. So after that, there is in customer or in a company or in environment, like the component is not affected. So the original design, like the example for the original designs are microprocessor, like telephones, like this. It is the original design. It is the new component design is called the original design. And then the next design is the adaptive design. So the adaptive design means after that the original design was implemented or implemented, then we need some changes. So for that purpose we need some modification to be developed. That is the adaptive design or novel design, a particular component. Then after that redesign. So redesign is the without any change the original design. Again we manufacture like iteration. So iteration 1, 2 without any deformations will be occurred in the original design. So the redesign will be done. Then variant design. So the variant design now we have some modifications because in original design or some things like if we have invented something now, then we have to add some additional features to the component. So for that purpose we have to modify the design. So the modified design is called as variant design. So the modified it is a similar thing. And then after the selection design. So the selection design is like similar to the variant design, but in some critical cases we need a performance. So that we have to invent a new design that our new design we have to invent a new component. That component didn't perform well or it did not meet our requirement. So we have to modify that design. So in variant design, we have to modify the whole things, or we have to modify our 29 to 20%. So in selection design, we have to select we have to modify design and select a particular area or particular component. So it will affect the functionality, or we have to identify that the component will affect the functionality of the whole component or like this. So we have to only modify that component is called as the variant, that is called as selection design. So the difference between the variant design and the selection design now, in selection design we have to modify. It does not depends upon the customer requirement. Also, it doesn't. That means it doesn't depends upon the customer requirement, or we have to go to for iteration, or whether we need some modifications will be occurred, then go to the variant design. But in the selection design, we need we identify that, or we got the feedback from the customers, like thing based on the customer requirements or like things we modify in this particular component. That is called the selection design. And then last is the industrial design. So industrial design now, all the components are called as industrial design. So these are the types of designs. So basically we manufacture a component in the industrial design, all the things are to be accommodated. So the second steps are common steps. What are the steps involved in the DFM study? So the steps involved is what is the procedure? That means that we have to follow a set of procedures. Whether we have to invent a new component or we have an idea or if we have an idea, they have to develop a new component. So they have a set of procedures for developing a new component. The first thing is they can collect the feedback from the customers because and the customer is the basic things. So these are the customers are the consumers. So first thing is that we can get feedback from the customers. So what is our need, and then based on our need, based on their need, we get to segregate this. That means we collect the feedback from the customers. After that, we get to segregate this feedback, and then we get to identify that which priority is the main thing, or what is the need for the customers. Based on that, we have to create we have to develop and design. So before that means we have to modify or something. We have to invent a new component. The all things we get a customer feedback. So the first thing is customer feedback, and then after that we have to design was done. So the design was developed by based on the customer requirements. We have to design a component. So the design was done by the design department. After that, the selection period. After the design was over, and then we have to choose the selection parameters. We have to choose the material, and which material is the preferred or offered for the component. That means whether we have to manufacture a pen in a different. We have an idea to manufacture a component, a pen or something else. So the first thing was we have to design a component. Based on the customer requirements, we have to design a component. After that, we have to select the material. So which material is the appropriate for that component. So the pen is made up of wood or plastic or steel, like thing. So based on that, so the selection, that means the material consideration or the selection of material is the main thing for as in DFM, that means in production department. So after that, we go to for the best design. That means we have a lot of items. After the material selection was over, after that we have to segregate or we have to select the best design, and then go to for iteration or we have to done a number of ways. After that, after that we have to finalize. If the design was over, we have to select the best design. Okay. After that, go to for DFM study. So the DFM is we have a set of principles. So once the design was over, so we have to design. So what is the production requirement? What is the process need for to develop this component? And we have to self-evaluate that. So whether we can manufacture this component is possible, or then we go to for customer job order, like thing, and what is the surface finish, and also the material cost, tool cost, all the things can be accommodated in DFM or design for manufacturing. So after that, when we go to for the prototype model, so all these things will be considered, and then after that we go to for prototype model. The prototype is a simple model. It is we have to prototype that model, that design. And after that we go to for the once the prototype was over, after that we go to for production. That means what is the difference between the prototype and the production one? So in prototype we have to modify that. So for example, we have to manufacture a nut and bolt at different dimensions. Like in normal standard we have to M6, M4, M6, and then M8, M10. Whether we have to manufacture or we have to design a component, we have to design a board of dimension M7. So once that is the basic, that means based on the customer requirements, we need a M7 bolt and nut. So before that, before go to the production, we need they can develop a model, that is called the prototype. Once all the process over, then go to the prototype model. That means we have to manufacture or in nowadays they can use in additive manufacturing or in many other ways we have to develop a prototype. The purpose of prototype is we have to check whether it is functionality is correct. We have to check or it will be working in a functional mode. After that, once the prototype was over, then after that we go to further production methods. So these are the things, these are steps followed in the DFM study. So what are the advantages in DFM? So the DFM not only to reduce the manufacturing of cost of the product, but it also helps to reduce the time to market and the quality of the product. So it does not, that means based on the DFM, we have to shortlist it or we have to optimize the design. Which one is better or like thing. So that means the DFM will not incorporate. No? It takes much more amount of time to finalize the design as well as the process and the production as well as it leads to increase the time taken. So also if the time taken will be increased, now automatically the cost of the product will be increased and also we didn't achieve the market. So it also very important and also we did not achieve the quality of the component. So for that purpose the DFM will plays a major role in all concepts. Then it also provides the systematic procedure. So what is the systematic procedure now? So we got like a flow chart. So what are the process involved in this production or like thing? Then which one we have to do it first? Like in DFM we see about the flow chart. In flow chart the first thing was the customer feedback. So they can give a set of procedures. The first thing was we have to learn the feedback from the customers. Then after that we have to segregate this customer feedback based on their requirement like. So and also reduce in any reduction number of parts, reduce the cost as well as inventory. So it also reduce the cost of the product because it requires less amount of time or less time to develop the product. Automatically the cost of the product will be reduced. And also the DFM tools encourage the dialogue between the designers and the manufacturing engineers during the early stage of the design. So in DFM, in normal production, that means the design department was segregate or separate, and then also the production department was separate. So there is no interaction between the design and the production. So in DFM, we have to encourage or we have to discuss these things. Whether once the design was completed now, the design engineer will discuss with the production. That is called concurrent engineering. So they have discussed between them and they have to find us. These things cannot be done or in that design process or in that component. Then we have to go to for outsourcing like things. So they can finalize whether they can be modified a component or not. Like so we have to design these things. After that, what are the factors to be considered for manufacturing? So the factors are product complexity, product variant, component availability of price, reusable design, failure analysis technique, managing design cost, incorporating production, product quality and quality standards. So these are the factors. That means these are the for example, whether we have to purchase a mobile. So what are the factors to be considered? So where we have to consider like RAM and also the display content like. So whether we have to manufacture a component, so these are the factors we have to consider. So once the product will be in quality and also it can be used for different components and also price and it can be reusable like. So these are the factors we have to consider before the go to for manufacturing. And the material selection. So material selection is the main thing in product in PDM. That is the product design for in manufacturing. So what are the factors? That means we have to consider the properties of the material, structure of the material and also the processing of the materials. So these are the main things we have to consider while selecting a material and also it is suitable for our component like this. So these are the things. So the basic principles are the main difference between them. So whether the tolerance, clearance and then allowance. So Why we can wait? That means without tolerance we can't manufacture any single component. In drawing, in all of them see about the industrial drawing. So in industrial drawing they can give you an exact value like 10 mm. So in practical method we can't manufacture a component in an exact dimensions. So it needs an allowance or tolerance value. The tolerance that we need an allowance value, we need a value. That is whether it may be plus or minus, depends upon the machining. So the machine will be whether we have to manufacture a component in lathe, so it required some allowance. In lathe, so the depends upon the machining, the quality will be different. Whether we have to turn a component, that means the facing operation will be done or turning operation will be done. Whether we have to do in a lathe and also we have to done in a CNC, the difference will occur. In CNC we have to achieve in micron level, but in lathe we cannot achieve in the micron level because it depends upon its specification or the requirements and also the things. So in nowadays or in normal condition, in actual condition, any things that means any component can be manufactured with an exact dimension. So we need some allowance, we need an additional value. That additional value is called as the tolerance values. So mainly the tolerance is suitable for manufacturing purpose. For example, here I will show an example whether we have to drill a component. So the diameter of the drill is m7. So we can't drill a hole, we make a hole of 7 diameter. So it need in additional they can be whether it may be the hole may be 6.8 or 7.2. So for that purpose we give some additional values. That additional values is called as the tolerance values. So here, so how the tolerance can be specified? The tolerance can be specified by the geometry and then size. So how the geometry? The geometry, based on the geometry, we have to segregate into two types. That is the limit tolerance and then plus or minus tolerance. Or the another name for plus or minus tolerance is called as the bilateral tolerance. So the limit tolerance we have to specify that the hole diameter will be from 10.2 to 10.6 like thing. So we have to fix that. Here the limit tolerance is the 12.75 to 12.25. That means the shaft diameter, the length of the shaft will be 12.75 to 12.25 like thing. So another tolerance is the plus or minus tolerance. The plus or minus tolerance, the other name for plus or minus tolerance is the limit or bilateral tolerance. So plus or minus it can be classified into unilateral and bilateral. So unilateral we can give the value only in positive direction or in negative direction. And the bilateral tolerance we can give the value in plus or both directions, plus and then minus. Here an example for the unilateral and bilateral tolerance, whether we have to manufacture a shaft or a block of length of 2.50. It is the actual size, but we can't manufacture in their actual size. So we can give the value of. So minus plus 0.0, we can the A represents the only in unidirectional values. That is the minus 0.05. That means we have to machine or manufacture a component 12.50, then minus 0.5. We can get the value of 12.45. So the length value between 12.45 to 12.30. So we can accept that value. So it is the example for unilateral tolerance. In bilateral, we can give the plus or minus values. So plus or minus 0.5. So the diameter is 1.05. So 1.05 plus 0.5. It is the 1.06, and also we have to minus that. That is the 1.00. So the diameter of the hole varies from 1.00 to 1.06. So between that we have to accept these things. It is the purpose of tolerance. So second, and then allowance and clearance. The tolerance is used for to manufacture a component, and the allowance and the clearance are the things. It can be mainly used in assembled components. So what is the difference between the allowance and clearance? The allowance will be used for maximum metal condition, and the clearance will be used in the minimum metal condition. So before go to that, so we have to differentiate between what is the maximum metal condition and the minimum metal condition. So the maximum metal condition, the material will be available maximum. That is the in shaft. Whether we go to manufacture a component or the 10 mm diameter shaft, 10.2, 10.4. Whether the diameter will be increased, automatically the middle availability of the metal will be increased. It is the maximum metal condition. In hole, we got to reduce the diameter, the condition will be reverse in hole. So the allowance is used for maximum metal condition and the clearance is used for minimum metal condition. So the both are used in the welding surfaces. The formula for allowance and the clearance is allowance equal to maximum MMC of the core minus MMC of the shaft. That is maximum metal condition of the core minus maximum metal condition of the shaft. So I will show you give an example for that and also the clearance also. So it is an example for maximum metal condition and then least metal condition. So based on the clearance and allowance value, we have to segregate the types of fit. So the types of fit is interference fit, transition fit and then clearance fit. So I will show you an example. So before that we have to simple calculation. After that we discuss about these things. So here the diameter of the shaft is 1.5 mm. The tolerance value will be 0.3 and the lower limit tolerance will be 0.04. So we have to calculate the allowance and clearance value. So the allowance value is maximum metal condition. So the diameter of the hole is 1.4. So we have to add these things. Upper limit will be 0.03 and the lower limit will be 0.05. So 1.48 plus 0.03 is the upper limit value and 1.48 minus 0.05 is the lower limit value. So we have a calculation. The allowance for allowance maximum metal condition of this hole minus maximum metal condition of this shaft. So the hole and the shaft. So 1.43 and then 1.53. So the difference is 0.1 and the clearance will be reverse for that is least metal condition of the hole and the least metal condition of the shaft. So the difference is 4. So for allowance value is minus 0.1 and the clearance value is plus 0.05. So based on that we have to define which type of fit is suitable for that. So for the clearance fit, the shaft here the represents the tolerance is larger and the smaller, that is the allowance is positive and the 0. Now we can use it for the clearance fit. When the clearance is negative and the allowance is positive, now we have to for interference fit. Then allowance is negative and then clearance will be positive. Is go to for the transition fit. That means the here I will give an example for that. So the clearance fit now the hole diameter will be maximum and the shaft diameter will be minimum. And then interference fit is the hole diameter will be minimum and the shaft diameter will be maximum. In transition fit, the hole diameter and the shaft diameter will be equal or 0. Like that. So after that, these are the basic principles in product design for manufacturing. Then thank you.